Extensible string of length 5 is attached to one end of a fixed point P, which is 4 meters above a smooth horizontal table. The other end is attached to a mass of 5 kilograms, which moves in a circle on a table. If the speed of the particle is 3 meters per second, find the radius of the circle of motion. Alright, so it's a classic, I need to, where are my shapes? Ah, here we go. I'll take you. Okay, so I use a parallelogram with an ellipse. Okay, center of my ellipse is here. If I can actually, there it is. Green's a bad choice. Black. Okay, I'm happy with that. Now we're going to draw a line going straight up. Alright, and we're going to do the fixed point P here. All good? Now, what I'm going to do next is I'm going to draw, I'm going to use this weird line here, the pink one. Do you see that pink square at the bottom? Ever see that pink square at the bottom? That represents the mass. And what is the mass? So it's 5g going downwards, yeah? And what happens is it spins around a circle, like so. See the 3D-ness of it all? So that's what's happening. It's spinning, but it is in contact with the table at the same time. Is that alright? So, now, it's undergone a horizontal circle. It's not a rugby ball, it's an actual circle. It's just a 3D image. Looks like an ellipse, okay? Now, we know that this is 4, and we know the hypotenuse is 5, so what does that mean about the adjacent? 3. Would you all agree it's spinning in a circle of radius 3? Agreed? Okay. So when you do motion in a horizontal circle, there's two main things. First one is forces up has to equal forces down. Okay? Now, the first thing is, if you're 5g and you're sitting on ground, your reaction force upwards is also 5g. If I got a rope and started to pull you upwards a little bit so that I had tension, what happened to your legs? What would your legs feel? Would you feel heavier or lighter? Lighter. So your R value would go down. So for example, if tension took 2g, your R value would be 3g. All happy with that? Now the problem in this question is the tension doesn't go straight up. The tension is actually at an angle, like so. And this angle is a 3, 4, 5 triangle. So if you will, that would be angle A. And what we could say is cos A is 3 over 5 and sine A is 4. So would you all be happy with this is 4 over 5t and 3 over 5t? Because 3 over 5t is going towards the center of the circle. The 4 over 5t is going upwards. Okay? So if we did up versus down, what would up versus down look like now? Okay? So it would look like 5g going downwards equals 4 over 5t going, and then plus your reaction force, R. Is that okay? Now, what force aims into the middle of the circle? What force aims in towards the middle of the circle? 3 over 5t is the only thing, the tension is the only thing responsible for keeping this thing moving in a horizontal circle. Okay? So 3 over 5t is the centripetal force, and I have a choice between mv squared over r or m or omega squared. Which choice would you like to make and why? Huh? Yep, somebody did their research. It's a v value, isn't it? There is no angle per second, radians per second going on here. So that's not there. So we're going for mv squared over r. Are we cool with that? Now, let's fill in some numbers here. What's the m value? How heavy is it? What's the v value? 3. What's the radius? And that's a 3 and a 5t as well. Let's isolate t on its own now. I think we can get t on its own pretty quickly here. That 3 cancels with that 3. This 3 cancels with this 3 as well. In fact, all the 3's cancel. Huh? T is 25 newtons. That's your tension. Okay. Radius is 3 meters. Tension is 25 newtons. Reaction at the table. We need the R value. See the R value? 5G equals 4 over 5 times 25 plus R. 5G. What's 5 times 9.8? 49. That's going to be 20, isn't it? R equals 29 newtons. And we're done. Yeah. So this is 3. And this is 7. Okay. I think I started to describe this the other day. Do you know when you're younger and you go to the circus? Hopefully you do. I take my kids to the circus, right? There's a circle or a sphere, yeah? And sometimes what you get is these, you get these motorbike riders that they do the inside of the sphere, don't they? And their warm-up trick is they basically, world's worst motorbike, but here we are. Okay. So bad it broke apart. Anyways, they do this. They just go around the inside like that, don't they? Alright. And the deal is so I'm going to describe that motorbike rider as a particle now. Okay, so he's no longer a motorbike rider. He's now considered a point particle. Okay, which is a really small particle. And what happens is this particle will just keep going around this horizontal circle over and over and over again, okay? Now, at any point in time, what's keeping you... So, if you were on the bottom of the circle, of the sphere, your R value would go straight up. Yeah? But in this case, if you were on top of it doing a loop-the-loop, your R value would actually go down. It's basically like, it's like a tangent. So this is the tangent and you go back towards the center of the circle. It runs along, you did the circle recently, didn't you? The force runs along the circle. Okay, so that's basically the gist. So if this is the center of the sphere, the R value runs in this direction. All right? Now what we're going to do is we're going to figure out some values about this R value. Okay, that R value is broken up into two components. It's broken up into a red component, which goes towards the center of the circle. Then it's broken up into a green component that engages in the forces up versus forces down. Okay, so the first thing you're going to notice is that this 10G goes straight down. Now, using that triangle, okay, don't mind the colors this time. Okay, what's the radius of the sphere is? The center of the circle of motion, that's a 0.5, isn't it? So I'll put 0.5 here. You can do Pythagoras' theorem, and you can easily figure out that that's 1.2. So the actual circular motion is of radius 1.2. Is that alright with you guys? Now, the key thing here is the R value. Would you all agree that cos x is 12 over 13? And sine x is 5 over 13. I'll pause there. Case, what R value is the red line? It's R cos x because it's the adjacent. So what is it? 12 over 13 R. The green value? 5 over 13 R. Okay. So your job now is to find the radius. We already did that, didn't we? What's the radius? 1.2 meters. Okay, I'm going to pause. Okay, so we did up versus down. 5 over 13r. 5 over 13r against equals 10g. We got an r value of 130g over 5. What is 130g over 5? 130 multiplied by 9.8 divided by 5. Is it 26? Oh, sorry, 26g. Yeah, we'll take that. Grand. 26g. Now I'm going to do centripetal acceleration, or centripetal force, is mr omega squared. Only reason I'm using that formula is to... No, have to. Do you want to multiply by 9.8? What you got? 254.8 newtons. Okay, either or. And then, so the only thing keeping this moving in a circle is that red line, the 12 over 13r. And we know that the r value is 254.8. We know the m value is 10. We know the radius is 1.2. And the goal of the question is to find the omega squared, isn't it? So I could be quite lazy with this, and I'm just going to move the 10 multiplied by 1.2 is 12, is it? And that 12 will cancel. That 12. And just divide 254.8 divided by 13 and square root your answer. So could anybody do 254.8 divided by 13? And then square root it? 4.43? Now, for those of you who are new to this, it means how much angle you're covering each second. So it means 4.4 radians per second. So what that essentially means is, so see this circle here? And see this starting off point? Every second, I'm covering a distance of 4.43 times the radius. So this distance I covered here to here, that's 4.43 radius lengths. It's the same thing as saying, I say it's roughly the same thing as saying I'm covering like 238 degrees per second. That's how much angle I'm covering every second. Does that make sense? For any of that you missed, did anybody miss the first exercise, the A exercise? There's a lot of that stuff in there, conversions. What does rad actually mean? Stuff like that. Okay, you guys are going to do question 8, and I'm going to pause this video.